Welcome to another Arthur Does Math video. Since most of you watching this will have never seen one of my videos, I ought to tell you a couple things about them first of all. So this video is for my Secondary 2 class. So if you're here for my honors, Secondary 3 honors class, this is not the video you wanted. Yours will be coming later, or it's a different one. Second thing is, I don't script these. Okay, I know what I'm teaching, I know what I'm doing, but I haven't written it out yet. So sometimes I make mistakes, and that's okay. I also say a lot of random things. You know, whatever pops into my head just kind of comes out here, and I don't edit these, I just post them. So enjoy. Hopefully you can follow it and make some sense. So we're talking about section 9b here, and it's missing lengths of right triangles. So you are going to need to get your notebooks out and create a new section. And we're going to call it stay together. Missing lengths of right triangles, because ain't nobody got time to write that word out. Okay, so last time we learned about the three basic trig functions, which are just showing relationships between sides. We learned sine, cosine, and tangent. So you're really going to need to know that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Because now, what our goal is I'm going to be giving you a triangle, a right triangle, and asking you to find some information. So the first thing that I have to give you, though, is an angle. Let's say that this is 43 degrees. Okay? And let's also say that I gave you this side. Say this side is 13. And I'm asking you to find a missing side, call it x. Okay? So there's a process that I want you to write down to approaching these. And it comes in 3 steps. Okay? Step number 1, and these are all in the form of questions that you should be asking yourself. First thing you say is, ask yourself, what do I know? Okay? What do I know? Now when I say that, I mean, what do you know about the triangle? Okay, so we know 2 things. I know this is 13, I know this is 43, but more along the lines, I'm asking you, do you know the opposite side, the adjacent side, or the tangent side? Okay, so when I come over here, I'll often label this. So number 1, here's my angle. So I know we talked about theta last time. Theta always represents an angle. Well, this time instead of theta, they just gave us outright what is the angle. So in relation to the angle, this side 13 is my adjacent side. So I know the adjacent side. All right. Question 2 to ask yourself is, what am I trying to find? Okay, and again, that's in terms of opposite, adjacent, and tangent. Okay, so to answer that question, I'm looking at what is the x. What side is this x? Wow. Alright, it's late, and you guys are supposed to call me on my mistakes. So, why did you let me do this? Sorry. Hypotenuse. I don't know why I'm writing tangent. It makes no sense. Tangent's not even a side. It's a relation. Anyway. Because x happens to be the hypotenuse. It's the longest side, it's across from the right angle. So I'm trying to find the hypotenuse. Alright, and then the third question for the setup here says, what trig ratio uses, I don't want to call it parts. Yeah, sure. Uses parts 1 and 2. So meaning what trig ratio uses the adjacent side and the hypotenuse? So that's why you got to know your sine, cosine, and tangents. Just in case we forgot. Sine equals opposite over hypotenuse. Cosine equals adjacent over hypotenuse. And the tangent, there's the tangent, that's where he belongs, is the opposite over the adjacent. Okay, so looking at adjacent and hypotenuse, I know that I have to use the cosine. Okay, so the answer to question 3 is the cosine. Now, this is just kind of a setup. Now I know how to approach this problem. Okay, so what I want to do is I want to set up this trig ratio, and I got lazy. I should have put theta on here. I'm going to put theta right here to remind me I got to use theta. So what I can do is I can say that I know the cosine. Now instead of theta, they gave us an actual number, so let's do that. The cosine of 43 degrees is equal to the adjacent side, which is what I know. Okay, I could have put that here and here. So I know the 13 over x, which is the hypotenuse, that I don't know. Okay, but this is just an equation. I can solve this. I only have one unknown. But to do that, you need a couple of tools that we haven't talked about yet. Now, the first is a calculator. Graphing calculator preferably. Most of your four-function calculators will do this now if it's some form of scientific calculator. But you'll notice that there is, there is a sine, cosine, and tangent button. We're going to make great use of those. But before that, you need to be very aware, because my calculators in my room are shared by my secondary 3 students as well as my secondary 2 students, that you go into this mode button right here next to second. In secondary 2, we work in degrees. So that third row down, you need to make sure that degrees is highlighted and you push enter. If it's not, please change it. And then my other students, when they get a hold of them, they'll need to know to change it back. So again, anytime you borrow a calculator from me, the first thing you should do is check the mode. Okay, then you can hit second quit, and we're good. So you can find things like cosine of 43. You just type it in, cosine 43. Enter. It'll give you a decimal. Today, decimals are okay. Alright? Last time they were not, but they are today. So I could write that, but I'm going to wait for a second. I want to wait till the end to use my calculator, so we'll come back. Instead, what I need to do is just a little bit of algebra. Okay? How do I get something out of the denominator of a fraction? Well, I multiply by it on both sides. Okay? So this was my initial setup. Let's leave that alone and do this again. Cosine 43 degrees equals 13 over x. So I'm going to multiply both sides here by x. Multiply by x and multiply by x. So if I multiply by something I'm dividing by, those cancel out. So I am left with x times the cosine of 43 degrees is equal to 13. Well, a lot of students don't see it this way, but just like I showed you on the calculator, the cosine of 43 degrees is just a number. Okay, it's 0.731353716, blah 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 blah. Okay, and just like any number, if this were 2x, you would know to divide by 2, or 7x, you would divide by 7. Well, you can divide by cosine of 43. Okay, I shouldn't have put that number sign there, but I'm going to divide both sides by the cosine of 43 degrees. And the same thing over here, which means that they're going to cancel out. Okay, I'm going to cancel on this side. And I'm left with this, that x is equal to the 13 over the cosine of 43 degrees. Awesome. This is just a number that I can type into my calculator. So let's go to the calculator, clear that for a second. I'm going to type it directly in. I want to do 13 divided by the cosine of 43. If you wait to do this division till the end, you're going to get a more accurate answer, which is why I didn't want to put the decimal in up here. I want to wait till the end. So 17.78. Okay, let's go 2 decimal places here. So that tells me that x is equal to 17.78. There were no units that I listed on there, so we would just leave it as 17.78. We're good. Okay, and it makes sense because this is longer than 13, which is what it should be, because it's the hypotenuse. It's the longest side. So this is the process that we're going to go through for solving all of our sides. And we're going to use those 3 questions each time. Let's do one more example here. So if this was example 1, I'm going to box this because it's really important. In example 2, we'll put here. Let's do a triangle, a right triangle. It looks something like this. Let's call this x. Let's call this 15. And this angle in here, we're going to call 28 degrees. Alright, so let's go through my questions again. Number 1, what do I know? Well, there's the angle, so I know the adjacent side. It wouldn't be a bad idea to write what that is, 15. Number 2, what am I trying to find? Well, this time I'm trying to find the opposite side. This is the side that does not touch theta. So it has to be the opposite. Opposite, which is x. So question 3, what trig ratio uses both of those parts? Well, that would be tangent. So I'm going to use the tangent of theta. Okay, so I can come and I can set up my equation, and I can say the tangent. Now instead of theta, we're going to use the degrees. Whoa, 8, come back here, 8. 28 degrees is equal to the opposite, which is x, divided by the adjacent, which is 15. Okay. Now we're just going to do a little bit of algebra to solve for this. So, starting over again, tangent of 28 is equal to x over 15. I'm going to multiply by the denominator. Okay, that's always my first step. Multiply by the denominator. Those cancel. So I get 15 times the tangent of 28 is equal to x. Well, I'm actually done here. That was a lot nicer because x is now by itself. Before I had to do 2 steps. Well, this one's nice. So now I can just go to the calculator and type it in. Get back here, calculator. I don't know why it got so dark all of a sudden. So this time we're going to go 15 times tangent of 28. It tells me 7.98 when you round. Okay. So 7.98 equals x. There we go. Makes sense. It's shorter than 15, the side that I knew. It's the shortest side. We're good. Okay. So most of your assignment looks like that. Again, please talk about this with your friends and make sure we're understanding, we're trying to set up, teach each other. I know you don't have a chance to ask your questions right now, so it's really important that you vocalize your ideas with each other. Now, on your assignment, which I have right here, the first page is just doing what I already showed you. Okay, it's solving for missing sides. Make sure you remember theta is always the angle they give you, not the right angle. So we don't want to use that. This one I do want to point out, though. This says find the length of each side, that there are 3 sides. So notice there's no x on this. So it's your choice. Where do you want to put the x? Okay, maybe I want to start with this side being the x. Okay, so I'd ask myself my 3 questions. I'd set up a ratio here. I might just get you started here. The ratio that I have is opposite over adjacent, so I know that the tangent of 62 is equal to 22.6 over x. Okay, we'd multiply by x and divide by the tangent of 62, and we'd solve for x. Now, once you've done that, you need to find the second side. Call it y. Alright, now you could do something similar. You could use trig, but we learned a tool last time. Actually, you learned it long ago, but we reminded ourselves last time of a tool called the Pythagorean Theorem. So once I have x, I can do x squared plus this guy over here squared is equal to y squared, and just solve for y, and that's probably going to be a little bit simpler. Okay? But you could just as easily solve for the hypotenuse first and use the Pythagorean theorem to solve for the remaining third side. Okay? It's really up to you. You have a lot of freedom with that one. Now, I want to talk about the back of this assignment. 9 through 14 are really as easy as they sound. Oh, round to 3 decimals. You're going to type them in your calculator. Go to calculator, sign of 9, enter, give me 3 decimal places. Perfect. You're good. Now, 15 through 19, I really do want you to try. Okay, I know you see story problems, you freak out. I don't get it, we throw our hands up. At least try and draw me a picture. Okay, half the battle of a story problem is having the confidence to start. Most students won't even start because they just say, I'm terrible at these, I'll never get them, blah, blah, blah. I've heard it all, and I don't believe any of it. Okay, you live in the real world, and while these are not perfect real world examples, you guys come across problems you have to solve all the time that are not laid out in a nice little formula. Okay, so you have the processing power to do these types of problems if you'll at least give yourself a chance and not be afraid to struggle and be willing to fight through it. So there's my pep talk. Go get them. Anyway, I want to set up 15 for you. Actually, I want to do 15 for you. So, oh yeah, the angle of depression. We didn't talk about that. Back to your notes real quick. Okay? We need angle of, we'll start with elevation, and then we'll talk about angle of depression. So angle of elevation is the angle formed by the ground to the top of some object. Okay? So if this is the ground, and let's say we have like a building here. It's a building. There's the door. Happy little windows. There you go. Okay? And maybe you're standing over here. The angle of elevation would be the angle from your line of sight up to the top of the building if you were going to look up. So how far did you have to move your head? Alright, so it goes from looking straight ahead to looking up to the top. You're elevating, you're raising your eyes up. And how many degrees did you have to raise that up? Angle of depression, on the other hand, is just the opposite. Okay, it's not just sad angles. No such thing as sad angles. Just angles that are looking down. Angle of depression. So I draw this picture. Please don't, read too much into it. Don't. I know what you're going to say here. Okay. Let's say there's this guy at the top of the building. However, there's a nice big safety rail here. He's not depressed. He's not going to do what you think he's going to do. Anyway, so angle of depression is how far, let's say there is okay, this is my sad attempt at some sort of creature. Call it a cat. That's a cat. It's not terrible. I've done far worse in the past. So the angle of depression is if you look straight out, okay, what is the angle that you have to move your head or your eyes to look at the cat? Okay. That angle. So it's looking down instead of looking up. The angle of elevation is looking up. Okay? So now we can talk about the assignment. Forgot about that part. So, the angle of depression from the top of a lighthouse, 150 feet above the surface of the water, to a boat is 13 degrees. How far is the boat from the lighthouse? Alright. Lighthouse time. There's a lighthouse. Okay. It's beautiful. Here's the water. Here's the boat. Okay. Drawing pictures is your best friend with story problems. Okay? So I strongly recommend, no matter your art skills, as you can see, mine are awesome. So you can do it too. Now, the angle of depression, again, we start looking straight, and then how far down did it have to go? Okay, so my angle of depression is right here. This is this is 16. We're doing 15. I'm drawing it in 16. I'm sorry, but I'm set up for this. So 13 degrees is my... It's just bugging me. You still have to do 16. I just had to get it out of the way. 13 degrees is the angle I'm moving down. Okay. Now, how far is the boat from the lighthouse? Well, it wants to know what is this distance. Let's go red. What is the distance from the lighthouse here to this? That's x. Now, you can look at it that way, or you could also say it's the same distance as up here, right? This side of the triangle is x. Sorry, I ran out of space there. Which means that I can form a triangle now looking down this way, okay, with the water. This is a 90-degree angle because I'm going straight down into the water. So I have 13x, and I mean that's, oh wait, do I know something else? Oh, the lighthouse is 150 feet tall. That's kind of important. Which, if I look at it, is the same as saying it's 150 feet on this side. Okay, can you see how this side over here is the same as this side over here? Alright, so the picture helps you set it up. If it's easier to pull it out then, after that I've got a triangle set up like this. Here's x, here's 13 degrees, here's 150 feet. Okay, that's sometimes helpful. So, we ask ourselves the same question. What do I know? So number 1, I know the opposite side. Number 2, what am I trying to find? Well, that's the adjacent side. 3, what trig ratio uses both of them? That's the tangent. So, of theta, what I can say is let's use the tangent of theta is equal to the opposite, 150, divided by x. Okay, so I don't have a lot of space here, but I would multiply both sides by x so that I get x tangent of theta equals 150, and then I would divide by the, no, sorry, this is 13. Like I said, unscripted. Then I would divide by the tangent of 13 so that I get x is equal to 150 over the tangent of 13, which is something you can type into the calculator. Come here, calculator. 150 divided by tangent 13. Helps if it's on. Alright, 150 divided by tangent 13. Go. 649.72. Okay. My space usage is struggling tonight. So we're going to come down here, and I get 649.72, and it's a story problem, so you got to have units. All right, right there, feet. Now, again, try these. Draw me some pictures. Okay, give it a shot. If you're wrong, that's okay. We'll fix it. But it's so much easier to fix a mistake that you've actually made than to try and figure out what mistakes you would make if you tried. So please do that. There's a freebie. It's question number 15. Okay? And from here you can get started on your assignment. Feel free to watch this video again or just certain parts if you need it. And I'll be back to answer your questions on Tuesday. Good luck.